hopefully I have enough space for this. Not here. Yeah, did everyone understand what a concave edge and what a convex edge mean? Like if I copy this here, uh, new section. So many wires, man. There's the tab wire, there's the earphone wire, there's the charger wire. So yeah, this thing. So what the convex and concave edge mean? Does someone understand that? Convex and concave edge.
Minus is concave, right? Right.
Yeah, minus is concave, plus is convex. But what does that
So
actually mean?
yeah, concave. I can give one analogy. If you see the corner of the room,
Yeah,
two walls meeting, two walls meeting, vertical column.
yeah.
So that is minus, right?
So this
Not three, two,
two walls, this.
two walls.
So
No,
this should be minus.
no, no, no. Where minus is written here.
Yeah, but minus is written here. But what is the understanding that this is a concave edge?
Basically, convex means wherever the edges meet, the matter is within the uh, intersection of those two edges, while concave says uh, the matter is outside those edges.
Yeah. So here imagine that this is a 90-degree angle, right? So if there's anything in this 90-degree angle, then it's a convex edge. If the actual matter is inside the reft, rest
270.
270-degree angle, this one, then it's a convex. Then that's a concave edge, right? So here we can see that much of the matter lies inside this angle in the 270-degree part, right? So that's convex. While if we compare something like this, if I take this right angle, right? So the entire box is inside the 90-degree angle, right? And in the 270-degree part, there's just the empty space. So that's the difference, if that makes sense. So those are the difference between like a convex edge and a concave edge. And yeah, arrow should be something understood, right? Plane to the right.
Right hand thumb rule in physics, right?
Sorry.
It's like a right hand thumb rule.
Yeah,
So the curly uh, curve mention matter that side.
yeah. So the entire material is on the right hand side of this edge. So inwards, 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 inwards. Just right hand. Okay. So I think that's the most simpler one. These two are the ones that I did not understood yesterday. I understood them today because of this thing. So I just wanted to mention that. Next is this. I don't think this is something we need to memorize. This should be given because this is hard to memorize. There are 18 types of vertices. Okay, so if we were to categorize them, vertex categories, the ones that I can think of on the top of my head is firstly y1, right? Y edge, no, y vertex, right? No, y joint. The example would be something like this. Here you can see a Y forming. The next one would be a W joint. This example is something like this. Here a W. This is again a Y1. This is also a W because it's just a W but rotated uh, clockwise angle. Sorry, rotated in the clockwise direction. This is also a W, just rotated in the anti-clockwise direction. Then there's, I think, T joint, and then there's the L joint. Am I correct?
Yes, yes. TWYL. I remember like that.
Yeah, so this one is the L joint, right? This one is also an L joint, again just rotated counterclockwise. And a T joint can be, what can be an example of a T joint? T joint, ACB. We don't see anything like this happening.
Yes. In this figure,
Not in this particular. No, no, no. There is no T joint in this particular model.
Yeah, but
There are
they can be like something like this.
there can be, yes.
So that's a T joint, and that's the vertex categories. Then there's the edge constraints. That okay, these are the constraints. Not something to memorize, I suppose. And then there's the connection. Okay, and consume. First and interesting application. So this is model-based diagnosis. It's an application of this idea that in this way we can identify any trihedral object and differentiate between the object and the shadow. So this is an application of that, and this is something, what can I say, so this has some discrete maths involved, like something what do you know what an implication is in discrete maths? Implication, it's just an if else
then
statement that if A then B, and the truth table looks something like this, that if true true, false false, true, sorry, A implication B, right? And this can be true false true false. So if A and B both are true, the implication is true. If A is true but B is false, so the implication is false. But if A itself is false, then the implication is true. Okay. This part has already always confused me, that why does this happen, that whenever A is false, the implication itself becomes true. But I'm not sure about that. I'll have to look that up. But this is the truth table, and in the course I think the implication is written as something like this, that A is a variable, B is a variable,
reverse.
and they are implicated such that if A is true, then B happens.
And I think that symbol is reversed.
Is it reversed? Okay, yeah. Sorry, not the subset symbol. This, that if A, then B. Mm, I'm not too confident going over this. If anyone else knows, maybe we can go over model-based diagnosis, but if not, then we can just skip it. Okay then. So CSP solvers. Some informal terminology. A and this and backtracking. So this is the backtracking algorithm, which is essentially just, this is just DFS, correct? Because it works in a similar way how DFS works, and even the conditions are similar to DFS itself. Sorry, even the pseudocode is similar to DFS. And this is a map coloring problem, and maybe we can just solve the question for this instead. Is Sujay not joining?
Yeah, I'm here.
Oh, you're here. Okay. So, do you know model-based diagnosis?
No, not comfortable.
Okay. So week 11, constraint satisfaction problems, I suppose. There's nothing else to do here until much later, where we cover arc consistency. So maybe we should go over this. I think this should be an extremely long one because like we have to cover the entire week 9 and entire week 11. So is that okay? Or should we split this into two? That for now we do week 11, we do week 9 maybe at maybe tomorrow or something, or just take.
I'm okay with the stretched one.
You're okay with a
I'm
very long
okay
one?
either way. Yeah, even I'm okay.
Okay. Okay, so just one marathon type. Okay, cool. So for a coloring problem, the map and the domains are given below. Two regions, two regions are neighbor of each other if they share a boundary, line or curve. So AB are region, AD are region, but EA are not region. Sorry, AB are neighbor, AD are neighbor, AE are a neighbor. Okay, and model this as a problem. Model this problem as a CSP. Okay, so when we say that we need to model something like a CSP, do we need to write the three things in the tuple, X, D, and R? I think it was R. Let me check the notes. That whenever we say something is a CSP, we define this by writing a triple, and the triple is defined as X, D, and C. Okay, so CSP is a triple, is defined as a triple. X, D, C. X is the variables. X denotes the variables. D denotes the domains, and C denotes the constraints, right?
Correct.
Constraints, or in mathematical terms, we can just say relationships or relations. So here we are being asked to to model this problem as a CSP, and we are given the domains here. Let me just copy this. So before even like starting the assignment, maybe it will be a good idea to go over how we can write it as a triple here, right? For understanding
Are
sake.
you saying about matching diagram?
Sorry,
Are you talking about matching diagram?
matching diagram mean this one.
Writing all domains and putting the variables inside and
No,
try
no,
to match with
just in a rough way. That
okay.
so X would be, we write it as a set, right? Let me just check this again. Constraint satisfaction. Yeah, so we write this as a set. So here our variables are a, b, dot 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 till f. Correct? The domains for each variable are dA, dB, and dot 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 df. What would the constraints be? C. So C is a set of relations on subsets of variables. So how do we write this constraint itself first? Mm, okay, so constraints are already given here. So constraints of the form R, X, Y are shown below. Okay. Before that, so if we take this example, there are four variables, there are four domains, and then there's the constraint that there should be a relationship between C and S, C and R, and C and F. So this is a binary constraint problem where every constraint is a binary relationship, and each of the relationships are given here. That C and F is a tuple between firstly there's AI and DK, AI and DK, because currently we are going over course and faculty. So DMGF again okay, so these are just course and faculty tuples. These are course and room tuples, these are course and slot tuples, and these are faculty and slot tuples. Okay.
So we need to write R subscript AB, R subscript like that.
Yeah, something like that. So if we go over this firstly, that
R subscript
so
AB,
yeah, R subscript AB. So this is our first
R
relation
subscript
between A and B. Then R
AC,
subscript AC, because again they share a border. Do
R
A and
subscript
D
AD.
are A and D tuple? Sorry, neighbors.
Yes. Otherwise the shape will be same color, no?
Yeah. So R A and D. We don't need to write R A and E
No,
because
they are not related.
yeah, because they are not neighbors. So we can move ahead to R, B, and A. Repeat that. R, B, and C. R, B, and D. R, B, and E. R, B, and F. And that's it, right? C would have something similar. So dot dot dot. RD would be again, it will be with A, B, C, D, right? RE would be with B, C, E, F. Yeah, B, C, E, F, because the E has and D, sorry, because E has four different neighbors, B, D, C, and F. So those would be the four relations I think. And for F, it will be just B, E, and C, right? So that's the assumption that these would be the different kinds of relationships. Huh, okay, and we just write something like that. That there would be a lot of such, and these would be again binary constraints, right? Because we are just talking about two regions at any given moment.
Yes.
Or F would have something like that, and each tuple would look something like okay, no, let's
We can
leave that.
try to write RA.
Sorry.
We can try to enumerate values of RAB.
In what
R
way?
subscript, R subscript AB, we can write it as red and blue, red and green, like that.
Okay, in that way. uh, yeah, so R subscript AB would just be DA cross DB, right? And from this, so this is the relation itself, because this will create all the pairs, something like that.
You
R
can,
R,
instead of equal to, you can write it as subset.
yeah, subset.
Right hand side is
Yeah,
Cartesian product. We are taking subset.
subset. That's a lot better. We are taking a Cartesian product, but also we are removing any such pairs where x equal to y. Correct?
Yes.
Where x equal to y.
Fine.
So this is just the set difference notation, right? Is everyone comfortable with this? What we have written here?
Now you have to write equal to after removing.
After removing what?
You removed no from the Cartesian product. You removed x equal to y. Then it will become equal to no
Yeah,
RAB.
yeah. Then we are doing exactly that. Yeah. Yeah, so I think this should be a way of representing the relationship between A and B for this constraint satisfying problem. Is this clear to everyone? Can I just get a yes or no?
Yep.
Yes, yes, yes.
Yeah, okay. So let's just see if the these are doing if the slides are doing it any differently. So a network is said to express a solution rho. Rho is equals to RCSRF is a relation of all variables. And okay, I don't remember seeing such a notation anywhere. This is just something that we came up with right now. Okay, let's leave that. Focus on the question now. So constraints of the given constraints of the form Rxy are shown below. This is the constraint 1, constraint 2 and constraint 3. Replace the labels x and y with appropriate variables to generate constraints for the given CSP. Which of the following are true for the given CSP? What does that mean first? Like, replace the labels x and y with appropriate variables to generate the constraints for the given CSP. Which of the following are true for the given CSP?
Appropriate variables are in the options.
So
APA,
RBA is an instance of constraint 1, RAB is an instance of constraint 1. Okay. So constraint 1 basically says that if there's an R, the next one can be either blue or green. But if the first one is blue, then the next one can either be red or green. It just again means that x and y should not share the same colors. And I think we know which variable has the domain RB. It is A, right? A and F. These are the only two ones that have the domain RB. And then RBG is something that B and C have. So I'd say A and B should be one. RAB is an instance and RFC is an instance, yeah, of constraint 1, and RFB is undefined. It shouldn't be undefined.
Why not RBA?
RBA means that B satisfies this constraint. But we know
YX.
B satisfies this domain, right? That we can input B as X. But we already know
Okay.
that the domain of X is
It only
RB.
has two.
Sorry?
It has two elements in domain of A. That's why.
Yeah, so it can't be X because the domain of X and domain of B are not the same. The only variables who share the same domain as X are A and F. So that can be one. So RAB is an instance of constraint 1 and RFC is an instance of constraint 1. I think that should be correct. Hopefully. Okay, that's correct. Yeah, in continuation. Okay, so I'll just open this separately.
Why not FD? FD.
FD is undefined, but FD can't be undefined because firstly RFD, so we can see that F is RB and D is RG, right? So B and G is still a relation possible between them. Let me try and draw that. So this is not something to do with constraint 1 itself, okay? So F and B, where should I draw this? Question 1, RFD is undefined, is not undefined. This is my understanding. Please do say if I am wrong. I can be wrong. But these are the domains of F and D. F is R and B. F has R and B, right? And D has R and G. R, G. So I believe this relation is possible, right?
BR also.
And yeah, BR is also possible and RG is also possible, right? So these relations are possible, and because of this it can't be undefined because we have a way of denoting our FD. Does that make sense?
Yes.
Okay, so RFD is undefined. RFD, I don't know what an undefined relation means. I believe it would be when it's invalid itself, that we have something like let's say X is and Y is,
Both are.
yeah, that both are. So here we can't add anything. So this should be undefined, I suppose. But if there were to be any different variable, like let's say if I just add b, then this suddenly becomes possible. Then it becomes defined. Maybe it's that.
Yes.
Should we ask this on discourse? Let's see. Okay, let's see. There are few more questions maybe. So in continuation to question 1, which of the following are true for the given CSP that so which ones satisfy constraint 2? Okay, let's copy this. Okay, so for constraint 2 we know that x has to have a domain of R and G, and we know that the only variable that can fit x is D because it has R and G, correct? So x should be D and y has RBG and RBG is B and C. So I'd say DB and DC should satisfy the constraint, the second constraint, and that's the only ones. And now this question, that R, B and C is undefined. So B and C is undefined. I don't think they are undefined because there's R. So R can
It's
have
connected
connections
to
with B and G both. B can have connections with R and G both, and G can have connections with R and B both. So it should not be undefined. So RDC and RDB. Okay. And in continuation to question 1, which of the following are given are true for the given CSP? So we are talking about constraint 3 now. So constraint 3 again, x is now a variable with the domain having B and G. The domain being the set B and G, and there's only one E. Only E satisfies x while y is satisfied by B and C, like we know earlier. So E and B should be the one true because there's no option for E and C, correct? Yeah. So in the given CSP, RAF is AF. Okay, let's try to write this. Question 3. So A is R and B, domain A. RA is this and RF. RF is RB, correct? And now we try to, sorry, why am I writing RD? It should be D, domain. RAF, like we defined the definition earlier, this definition, that the Cartesian product of the two domains and the set difference of this set wherever x and y are true. So it simply means that it should be something like RB and BR. That's really it, right? Only these two are possible.
Yes.
So just RB and BR, this one. Hopefully. RAF. So it is not this. The definition that we made is not correct. The set differences should not be there for some reason.
They are taking whole Cartesian product.
Yeah, they are taking the entire Cartesian product. Is that mentioned anywhere? Course room is a subset of courses and room. So where is that mentioned that it should be the entire Cartesian product and not
Let's
the
read it. In some slide, the given definition of C.
here itself? So it says this, it's a subset of, the subset is called the scope of relation. It is a relation on subsets of variables. So if we're just talking about relations, then the basic relation is the Cartesian product, right?
The full relation.
Yeah, like whenever we talk about relations and maths, we only consider Cartesian product, that I'm taking a relationship between real numbers and real numbers. So we take pair of real numbers. So I guess because of this, this set difference is not needed. But given that the problem we have should not allow that, okay. See, you
If
set
we remove that similarity, then our first three questions is inconsistent. No?
this question.
In first three questions, the diagram shows it's ignoring that. It's not
Yeah.
complete 2 cross 3, 6.
Yeah. Because the
Ignoring
relationship here shown is not between R and R, it's between R and B, R and G.
with the same reverse way, we should able to do like that only, right?
Yeah, so this should not be true, this should be true.
We should ask this. You can create a post now itself.
Okay. This goes. Chat. Okay. AI. What should the title be?
Definition of RA.
Clarification regarding definition of what a relationship means. Okay.
Should be very careful with the wordings.
Yeah, clarification for, sorry, definition for, what can I say? Maybe we should create the post after the class is done.
Okay, fine.
Yeah, because it would take like easily 15 minutes to fix the wordings and everything. I did get a good post, keep it up, but still it's not worth 15 minutes there. At least not now. Okay. Relationship achieves that. So our relationship is this. So a constraint is a set of relationships, correct? And a relationship is being defined something like this. So if we go by this, if we go by our definition that for this map coloring problem, this should be the relationship, then only the first three questions are correct. And the fourth question should be, the fourth question's option should be this. But if it's this, then it means that the definition for this relationship is incorrect. And if this is incorrect, then these three questions should be incorrect, but these three are correct. So what is true?
Inconsistency.
Yeah. Which of the following are the solution for the given CSP? The ordering is A, B, C, D, E, F. So if this ordering is given, then we are supposed to solve in this order.
Yes.
Okay, let's try that.
We can solve this question by two way. One is by algorithmic way and another is by options way, right?
By option selecting.
By checking each options
Yeah,
or
we can.
by going through the actual algorithm, match color,
Yeah.
graph coloring algorithm is there, no?
We should go
That is
through the
very
algorithm
big.
itself because if we can go over this itself here, we can see that many of these connections, many of these edges between two nodes are removed, and it leads to different. I mean, what it does is that it would automatically remove any kind of edges there. Edges which say that the two neighbors can have the same color. So we should go through that. Let's try it. So we should start. Okay, so should I make a graph first? Something like this.
This will take too much time actually.
Yeah, this would take too much time. So let's just try to do
Have
it
to
on this.
write matching diagram, then arc consistency, then we have to remove edges.
Let's try on this. Q5. That okay. Let's see. So this is RB, right? This is uh, this is just RBG, and this is also RBG, and the order given is A B C D E F. A B C D E F. So if this order is given, firstly it means that we need to solve for A and B, correct?
Yes.
Okay. So R.
First, let's do the easiest way.
Yeah.
Take
Okay.
all the options, then right for each option, let's fill the this given options, then verify it is consistent or not.
So this is R. This is B. This is B. And this is R. This is G. This is R. So these two match, right? Which shouldn't be possible.
We assume that like that
No,
that
no.
point is
I'm.
there.
Okay. I just filled this option in this
Okay,
order.
then we can verify later.
So this is R, this is R. So I'd say it shouldn't match because these two are having the same color. But if these two are not considered neighbors, just because this is happening, then it should be the correct answer. What it is saying, the two regions are neighbor only if they share a boundary, line or a curve.
Okay, it's
These
sharing
two
only
don't
point.
share a boundary. These two share a point. So that this is valid. So I'll say this is valid.
Should valid.
Okay. Then RBB GRG. RBB GRG. Yeah, this is also valid.
Yes.
Then RGG RBR. RGG
Sir,
RBR.
one more thing we are missing.
Yeah.
The given thing should be belongs to the domain also, no?
Oh, right, right, right. We haven't checked that. Yes. Okay. Let's check that too. So does this belong to the domain? Yes. 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 R belongs. E. G belongs. R belongs. Okay. So this is fine. This does belong to the domain.
No, that was not. R and R shared the boundary, no? DNA.
Yeah, but we just right now said that they are sharing a point, not a plane or a curve. Sorry, not a edge or a curve, right?
Line or X.
This is a point. So maybe they
Okay,
are
I
not
thought
considered
when there's
neighbors.
a boundary, it means the entire boundary. Like, anywhere, if it touches anywhere. No?
Yeah. So that's something ambiguous. We don't know. This can be that A and D are neighbors.
Okay. Okay.
We just check that. Okay, let's see. So we are saying that is correct. Is that correct? Yeah, it is considered correct. This is considered correct. So RBB RGR is considered correct. It's a solution for this map coloring problem. So that means that A and D are not neighbors. Okay. Next up is RBB GRG. RBB GRG. Okay. So R belongs, B belongs, B belongs, G belongs, R does not belong. Yeah. So this can't be a solution because R does not belong in the domain of E. Okay. Then next up is RGG RBR. GGRBR. Okay. So these three belong. This belongs, this belongs, this belongs. Okay, so this is an option. Next up is BRR BGB. BRR So this belongs, this belongs, this belongs. This does not belong. B does not occur in the domain of D. So this is not an option. BRR, GBG, just change the last three. GBG. So now this belongs, this also belongs, F doesn't, G doesn't belong to domain of F. So this is also not true. And then BGG, RBR. GG, RBR. So this belongs, these two also belong, R also belongs, B also belongs, and R also belongs. Okay, so this is another option. So RBB, okay, then RGG, RBR, and then BGG. Okay, so all five are correct, except this one for some reason. Okay, so that's one done. If the other one's similar to this, what happens?
Can we check is there any previous post related to this question? Complete and go.
Next up should be, what was the question? In the given CSP RAF, so practice assignment 1 CSP. The problem is that not many people use the right keywords in the posts they make on the forum. So because of that, even searching is really difficult. Practice 1 CSP. No. This one? I'm asking, consider the following. Okay, the regions A and D. Okay, so they are just talking about A and D here. Oh, no, yeah. Okay, so maybe we can just add here itself something. And so this is a big deal, that if RAF has this, then we are considering RR and BB, then we are considering two neighbors having the same color. So because of this, these things are not possible.
Inconsistent with the
Yeah.
first three questions.
So next, let's see the next one maybe. Okay, so this is about arc consistency. Okay. So the domain of x, y, and z is ABCD, ABCD, and RXY and RYZ is AB, AC, AD, CB, DB, DC. So these two XY and YZ both have the same relations. Okay, so it's really being denoted by this diagram itself. What is true about the diagram? It is the matching diagram of the given CSP. Okay, so we can check that. Should I zoom in? My god.
Okay.
Okay, 133% is the limit. Okay, so these are given as the domain and these are given as the relations, right? So it is the matching diagram, so we can just see whether AB has a node, AB, yes, or let's just copy this thing. CSP2 Q1. So let's just verify first. So AB, there is a node here, so this is correct. AC, this is correct. AD, this is correct. Then CB, this is correct. DB, this is correct. And DC, this is correct. And we can see that this more or less has the same shape as the previous one. This looks similar to this. Yeah, the edges match, so it should be correct. That it is a matching diagram of the given CSP. Let's have this maybe. Yeah. So what is true? If it is a matching diagram, it depicts the constraints Rxy and Ryz. It does. I think it does, because these edges show the constraints between x and y, that x and y are related in such a manner, and our xz is undefined. Xz is undefined in the given CSP. Okay, one thing about this is that see, from A we can go to C, and from C we can go to B. So is there a transitive relation between x and z here? Like this A is affecting C, which would in turn affect B in this way. So can we say that x and z are transitive? Ah. Can we do that?
You mean you are saying composition function?
No, no, like
Composite
there are three types of relations, right? There's symmetric, there's reflexive. I think there's firstly reflexive, then there's symmetric, and then there's transitive, right?
Transitive is not allowed in this, no?
Where is that mentioned?
I think in lecture somewhere he said, somewhere is in the notes also, if it is, if I'm not wrong, is there. You mean to by transitive, you mean to say A is to B, B is to C, then A is to C, right?
Yeah.
No, I think it's not allowed. I think it's mentioned somewhere in the notes.
I see. Okay. So R and XZ are is undefined if transitive relations is not allowed. But if it is allowed, let's suppose if it were allowed, then can we write in some way relation between R, X and Z? Can we attempt that just as an exercise? That if we assume that transitive relations are allowed between X and Z, can we write a relationship between them?
we can try
Let's try that just as an exercise.
A comma
So A comma C and C comma D, right?
A comma B.
Okay, we can just copy from this itself, right? We can just copy from this thing. That if that we firstly see A comma B and then we see nothing, right? So there is no transitive relation here, but we see A comma C and C comma B, so we can say that A comma B should be in the relation, right? That makes sense. If we see AD and then we see DB, then we can say A comma D should be in the relation between A and X, sorry, not X and Y, X and Z. And this is under assumption that transitive relations are allowed.
No, A comma D, how A comma D?
Because AB and okay, no, sorry, AC and CD. No, sorry, B, it should be B, yeah. Okay, yeah, it shouldn't be there. There's AB,
A comma B.
AB through this, A comma B, and then there should be AC, right? This and this. So transitively we can say that AC can exist. So that, so okay, it was a rather simple task.
Still one more is there, Ishan.
Oh yeah,
Comma
let's
B.
see that. This is CB. So we are talking about CB here. So nothing else in CB.
DC, CB.
AC, AC this, AD this. Then we DC and CB. Okay, yeah,
D comma B. Only three.
only three. So this is just a revision of something we learned in, I think, class 12.
11.
We learned it in class 12th, I think. And maybe this was in maths 1 as well in the foundation level. So just a simple thing, transitive relation here. So this is not allowed. So it should be undefined. But if it were defined, it were allowed, then it would be this, right? Okay. So it is a matching diagram and it depicts the constraints r, x, y and r, y, z. Okay. After making x r consistent with respect to y, what happens? Okay, so we need to now define what arc consistency means. And arc consistency, it just means that okay, so I'll just try to write the definition in a simple term here. Please tell me if I'm correct about this. Arc consistency so x and y are arc consistent if what can I say? So
To y,
if
there is
for all values in domain of x r xy is satisfied, right? Not just dx, I think in both and dy. Let's just try to write this in a better way. So what I think is arc consistent if for all values, let's say x belonging to d of x and y belonging to d of y, x comma y belongs to the relation xy. Is that correct? That what I'm saying is that for every value in the domain of x and for every value in the domain of y, if we take any pair of any such values x comma y, these satisfy the constraint represented by the relationship x comma y. Is that what arc consistency means? Yeah, it exactly means that. Yeah. Let me open the definition. I think I nailed that. Damn. Arc consistency.
one. Yeah.
I think I skipped that accidentally. Yeah, this one. See, it's exactly what I've written. That
It's if and only if.
yeah, if and only if. So just if and only if for all uh, every variable there is a value such that x and b is defined. So so this if is also important because it also means that for every pair of values that satisfy this domain, this means that x belongs to d of x and y belongs to d of y. Am I correct? Because if means there should be a positive implication as well as a negative as well as the reverse implication.
Converse is also true.
Yeah, converse should also be true. Does this make sense to everyone? Just yes or no?
So does this mean that all the elements will go with all the elements of the domain of y?
Yes.
So basically there are no constraints in this.
No. It means that I am picking any random variable x from the domain of x. Let me just, I think the lectures have it better. Instead of using x and y, they use x, a and b. That's a lot better. Okay, let me just change this first. A comma b A, B. Yeah, so this just means that let me just pick any value from A and any value from B, and let me make a pair of them, this thing, A comma B, right? So given that I have picked A from the domain of X and B from the domain of Y, this tuple that I am creating should satisfy the relationship between these two variables X and Y. Does that make sense?
I think once we go through the examples, you'll just understand better, maybe.
Yeah. Uh, okay. Let me try and okay. So what can we think about this? Uh, that suppose, let me try and come up with this example first. Let's suppose X is something like RB.
Ishan, Ishan, when we do the practice assignment, we will come across this, right?
Yeah, we will. We will in fact come across this itself. But
Yes.
again, Bhaskar himself said that whenever you come across a definition, you should try to come up with an example yourself. So that's why I'm trying to do this. Uh, so here, if we are taking about, if we are, so if we were to say that X and Y are consistent, so it would mean that all these tuples R comma B, B comma B, R comma G, and B comma G should belong to the relation given by X and Y. Does this make sense to you? Like what I did was just make pair of
Yes, yes.
every element from X and Y,
Mm-hmm.
right? And if
Yeah.
so, this is true both ways.
Got it.
Yeah. So it means that if X and Y are consistent, then this should be true. And if we know that this is true, then X and Y should be arc consistent. That's it. And Sujay, are we just doing this itself? Is this exactly what we are doing, Sujay?
I'm revising slides actually. I
Okay.
got lost.
Yeah, so what I'm saying here is that this is the definition of what arc consistent. This is an example of what arc consistency means. That X and Y are arc consistent. If I take every pair of every element from X and Y and it belongs to this relation, then it's arc consistent. So I can write this like this, that X cross Y is a subset of Rxy. Okay, maybe we should just move to the example now. Okay, so after making X arc consistent with respect to Y, okay, what happens? So X
To
and Y should
make
be,
R consistent, we should call that a revise function.
yeah, revise function. And what revise function basically does is that if it finds any such pairs which do not belong to Rxy, then it just removes them, right?
Remove from the domain itself.
Yeah, it removes both the elements from the domain. Like in this example, if I were to say that RB does not belong to Rxy, then remove R from dx, remove B from dy. Okay, so this is what revise does, that it goes over every pair, and if it finds any such pair, then it just entirely removes these two variables. If I were to write this in domain in set notation, I'll write this as dx set difference R and dy set difference B. Because I believe that only if we understand this we can even solve the question. Okay, so does this make sense? That whenever we find any such pair that does not belong to the relation, we just remove these two variables from their respective domains in an order to try to make x and y are consistent. That now we have removed the troubling elements itself, it should be are consistent. If it's not, then we again remove, and we keep on removing until the domain itself becomes empty, and once it becomes empty, then the relationship itself is undefined. The revise one is, yeah, it's just this,
Yes.
that for every a belonging to dx, if there is no b dy such that this belongs to rx, delete a from dx. Okay, so we do not remove b, we only remove so this is not true, it's just this.
Revise x comma y will remove x. Revise y comma x will remove y.
Yeah, so this is done by revise
X comma y.
x comma y. Let me try to clean this up for later. So revise x comma y if r doesn't belong, okay, r belongs to dx and
But there is no y such that r comma y.
how do we write no y? No y belonging to dx,
Capital dy. Capital dy.
right, dy, sorry. Dy such that x comma y belong to rxy. Yeah, then
These things will be cleared when we visit like slide number 51. Because these things are very much like maths, no?
yeah,
Pictorial line number.
yeah, that's why I'm trying to write as much mathematical notation as possible, because like at least for me this is easy to remember, and I think it should be true for all, that if we try to just think about it we can memorize this, and this symbol is not, right? Okay, so let's try and do this finally. I apologize for stalling this much, but just needed to clarify that.
To solve that question, let's take only x and y.
Yeah. So after making x are consistent with respect to y, so it means that we only keep on calling revise x comma y, because we are only
Also
making
y comma x.
x.
We have to call twice with y comma x also.
That's to make x and y are consistent with each other, right? Here what
Okay.
we are doing
That
is
is
that we are just
option
making
number
x
3.
are consistent with y. So I think we only
fine.
call this.
Yes, you're right.
The next question says with respect to each other. So maybe we'll come across that.
Yeah, we do that afterwards after this. So okay, domain is given, so I'll just again write this, that domain of a b c d, and relationship is given. I won't write the relationship. Okay, so now if we try to make this arc consistent, let's see that if there is a, is there any value in y such that a comma y is not in rxy, right? Because that's exactly what we need. Any value if there is no b. Okay, so we need just at least, even there, sorry, even if y has just one value that satisfies, that makes a pair with a, then it's fine. But if there is not a single value, then we remove that. Okay?
So I have to. I think it would be better put like this. If there is no outgoing arrow, then remove it.
Yeah. So here we remove B because it have no connections. Correct?
No outgoing arrow.
Yeah, no outgoing edges. And if we were to check the tuple itself, sorry, check the set itself, then we can say that okay, let's check for A first. Then for A, I can see that it forms a consistent pair with B. So that's fine. We skip on A, go to B. For B, we see that B never occurs in the first element. So B needs to be removed. Okay. Next we see next we check C, so we see that okay, there this element exists, and there, like, because this element exists, there is an outgoing edge here, so it stays, and similarly D stays. So the new domain just becomes ACD. So we only call revise once, or do we call it again on this?
Only once.
Only once. Okay. We keep on calling that in the arc consistent algorithm there. So after making arc consistent, RXY remains the same. Right. We also update RXY, right? RXY remains the same. I don't see how RXY would be affected.
It remains same.
Yeah, the domain is the one that's changing, right?
When we call reverse way, then it will change.
Okay, let's see that afterwards.
RXY will remain the same because the relations were already are intact, right?
Yeah.
If there is no edge is going from A to B, say, or X to Y, then there is no relation over there.
Yeah.
So RXY will remain the same.
And here too, we are only removing the thing from the domain itself, right? We are never even touching RXY. So it should
Yeah,
never
right.
it should never change. New tuples are added to RXY, again it is never changed. Some tuples are removed from RXY, it is never changed. The value B is deleted from DX. These two. Okay. After making both X and Y are consistent with respect to each other. So now let's do that for B. Let's do that for Y. So
We have to call
the incoming
revise Y.
edges. Yeah. So now we again just revise. So we have already revived X, right? Now we need to revise Y in such that it is also consistent with X. And in doing so, we can check for any incoming edges in Y, but I think a better, more consistent way is to go in each element of the set, check for any value of Y. If any value of Y exists, then it's fine. If it doesn't exist, then it needs to be removed. So here B exists, so B is fine. B exists as a Y value, so it is fine. C exists as a Y value, it is fine. D exists as a Y value, it is fine. And A never occurs. So A needs to be removed. This thing. And here too we can see that A has no incoming edges from X. So it makes sense. And this should become BCD. Right? So domain of Y. So RXY remains the same, yes, because we are only changing the domain of Y. New tuples are added and value A is deleted. So these two should be the same. RXY remains the same and value A is deleted. Okay, this was clear to everyone, right? Okay, I'll take a file.
Yes, yes.
And after making the network arc consistent, DX is okay. So do we need to make X and Y are consistent? Sorry, X and Z are consistent to each other? No, right? Because we do not. Because these two have no relation to each other.
No, they are also explicitly asking about X and Y only.
Yeah. Oh, they are only talking about X and Y. No, it is talking about after making the network arc consistent. So for that, you'd also need to make
have to call.
Z arc consistent.
But
Oh,
that is
okay.
X with Y and Y with Z, not X with Z.
with y and y with z. Yeah, that's what I'm asking. That because
Yeah,
the network needs to be made consistent, these two don't need to be considered anymore because
yeah,
these
right.
two have no relation.
Yeah.
Because again, as you said, transitive relations were not allowed. So,
So only
That's what I'm
CD will
I'm
remain.
thinking. I have checked that. Huh? I'm just someone please confirm because I think I have heard that during the lecture.
Yes, yes. We have to.
Can we say only CD will remain now?
yeah, let's do that. So so now what we need to do is that we need to make y arc consistent with z first, right? So if we try to make y arc consistent with z, so we can see that earlier in x b was removed. So logically b should also be removed from this. How?
Correct.
Because b never occurs in the first position, right? And now the first position belongs to y, the second position belongs to x. So yes, that's why CD would only remain, like as Sheval said. And if we talk about DZ, DZ should just become BCD, I think.
Yes.
BCD, because again A never occurs in the second position. So this is removed and BCD. Okay, so now the entire network is arc consistent. And after making the network arc consistent, dxy is
Nishan,
we are
Nishan, we missed one thing.
yeah
After removing B from Y, okay,
yeah
C from X will go away.
right. Okay,
Yeah, right.
yes. So that's why that's why the entire thing will not solve in just one cycle. That just because we have solved this now, because dy has changed, we need to now still make x consistent with dy, right? Hmm. So okay. So now because CD only remains, how can we go about checking that? So CD, so this needs to be removed, right? This thing. So A needs to be removed here. Is that what you're saying?
C,
C needs to be removed.
go away. Yes, because if you see X and Y, there is a edge from C to B.
X and Y, there is an from C to B. C to B, okay. And now B
When B
has
is
been
removed,
removed. Yeah.
then the C is not having any outgoing edges.
Yeah, okay.
So we have to remove C also.
Yeah, okay, okay. I was looking at the set here. So if we check this, that sure AB does not occur in the relationship anymore because B has been removed from dy, but AC still occurs because C still remains. So A should still be in X, right? Similarly, AD
Correct.
is also fine. But in CB's case, we can see that B now no longer exists in dy. So this needs to be removed.
So in that case, D will also go. Reason being, if we remove C, if we are removing B, C is going to be only, okay? So in that case, C will also go. If C is going for Y, then
C is going for X, not for Y.
uh, even from Y to Z it is going, no?
Mm,
Why will it go? C, why will it
no,
go?
C is still in the domain of Y, right? We are removing the C
C
from
from X
X,
will
C,
not
go.
this one still remains, right? What you are saying is that because we are removing C
uh,
from X,
D remains is.
yeah, D remains because even if we are removing B, there's this node, right?
Yeah, what I'm trying to say here is the network. Hello, am I audible?
Yeah, yeah.
So for if you look at when we are trying to make it arc consistent x to y and y to z in terms of the entire network, if we are removing from y, if we are trying to check y's arc consistency with z, and I'm removing c because b will also go.
B will go, yes. B from Y will
B
go.
is going,
Yeah,
yeah, b from y will go,
yeah, we are right.
and
Yes,
uh, okay, and c will remain.
yes, C
B will
will.
go, so C will also go.
Uh, B and Y will not go. Yeah, B goes. Yes, B and Y is removed. That's why I'm
I have
saying
a
that you should
suggestion.
not look for edges here. You should compare it with the set here, because we are not keeping track of the new edges, right? But we are keeping track of the new sets because it's a lot easier. Let me try and go over this once. So you understand why B is remained, by why B is removed, right?
Yeah, yeah, that is fine.
Right? B is removed because we want to make Y and Z are consistent, and B
Mhm.
never occurs in the first position of the
Yeah, that I
RYZ
got
relation.
it.
Yeah, that you got. Now you're saying that C
Yeah.
needs to be removed.
C, because B from Z. Okay, Z B remains. Okay, okay, got it. B
Yeah,
remains in Z. Okay, okay.
And I have another suggestion. How about writing this XYZ network and keep erasing whatever?
Exactly. That will be easy to understand. Actually,
Easy to
just
track
cross it
track
out.
also. You spoke ABCD. We lost which ABCD you are mentioning.
yeah. Okay, see, that's why we can definitely draw that, but I believe in the examination you won't be able to erase the edges, right? And the
Take eraser,
only,
no?
well, yeah, if you carry a pencil, uh,
Pencil eraser.
yeah,
I always do like that.
that's why I am more focusing on the set representation here, that this will not mess up.
Yes, okay,
See,
fine.
but Ishan, if you do that in that XYZ diagram, if you do that, for example, okay,
Yeah,
in case of DX, you have kept ACD, right? You have just removed that B. So if you cross out that B in X
yeah,
over there itself, in the diagram itself, see in the
okay.
set X,
So I'll just
that
cross
B is
this.
not going any. Exactly like that. So that will be
Oh,
easy
that
to
much is
understand.
simpler. Okay, so that much is understood. That, oh, sorry, not A, C here,
Not
right?
A, yeah.
B, because it has no outgoing edges,
Mm-hmm.
right?
Yeah,
And
yeah.
then
In
we
C, it
remove
should be
A as
A.
well because it has no incoming edges, right?
Mm. Mm.
And
In Z also, that A should be removed.
Z, yeah, this is removed, and that's
Yeah,
it. And now what
yeah.
we have done here is that now because B is removed, C
Hmm.
has an edge that only goes to B, and because of that,
Right.
C is removed.
Yes.
But again, set
Hmm.
notation, I see. um I understand this, that why this is a lot more pictorially, what can I say, understandable, but
Hmm.
I'll say the set notation is a lot more manageable in a way, right?
Okay.
That what we have done is that firstly we made x consistent with y, then we made y consistent with x, and because of that,
That way you get step by step things. Yeah, that I
yeah,
agree.
yeah,
Yeah.
and
That
you
makes
end
sense.
up with something like this here, that BCD, right? Then
Hmm.
next you make y consistent with z and remove this a, and you get here.
Yeah, I understood.
Now
That is
you,
also right.
I'm just counting the steps here, that you just now make z consistent with, sorry, y consistent with z, and in doing so you remove this b here. Why are we removing b?
Hmm.
Because b never occurs in the first position, and that's why we
Correct.
removed b and we got it here. Now because dy has been updated, we also need to check the other relations, because right now
Yeah.
what we were right now with the updates that we were doing for these two were for rx, for ryz, right? Because we updated these two while we were checking for this, but there are other, but because dy has been updated and dy has other relations with other variables, being our yz, we should also again check our consistency between x and y, right? Was that
Right.
confusing?
No, actually, I was thinking about something else. Like once we are done with this, we I want us to solve something, but that's afterwards.
Yeah,
First,
yeah,
we
yeah, yeah.
focus
Okay,
on
okay.
this.
So okay, we end up with CD here, right? We end up with CD. We have ACD, sorry, ACD earlier from earlier, and then we again check this set here. That okay, is a pairing possible? So A is allowed. A gets to remain because AB is there in the relation. We check for C. Is there any tuple that starts with C? There is no tuple that starts with C, so we remove C. Is there any tuple that starts with D? Yes, there is a tuple that starts with D. So we leave D as it is. Okay. So now this changes to A comma D. Right. Now because X has changed, should we also try to see whether Y are consistent with X, right? So if we do that, is C occurring in the second position with A or D? C is occurring with position A, okay,
Yeah,
that's fine. And D is also occurring with A, so that's fine. Now I think the entire thing is consistent. This, this, and this.
Still one more. D from Z will also go.
Uh, D from Z will also go. Yeah. Now because we have updated Y here.
Yes, it will
Because
go.
we updated Y, now this relation R YZ needs to be checked again. Okay. Damn, this is
Because
recursive.
it's the only relation coming for D.
Yes.
Yeah.
Uh, so let's see. CD, CD. Wait, what were you saying? Which one goes? B goes.
D will go because AD is the only relation for D in
D from
Z.
Z will also go.
And A is already
Right.
gone.
And if we check the, yeah,
But
so
that
this,
is that thing,
removes.
Ishan, is more easily visible in the diagram than this
Yeah,
thing.
okay.
Yeah, actually, this is what I was
Now
trying
I
to explain.
agree. Now I agree, yeah.
That's why I was saying D and then I got confused myself.
Okay, got it. So now I agree. So we need to carry a pencil and eraser for this.
Yeah.
A, B, let's do that. C, B, and this is X, and this is Y. This is again A, B, C, D. This is Z. A, B, C, D. Okay, so what are the edges like? They are like this, 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 and then there's this, and then there's this. Okay, and similarly we again draw with this, 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 and this. Okay, now we can try removing that. So we again remove, which one do we remove? We remove B because there it
First
has
B.
no
Yeah.
outgoing edges, right?
Yeah.
Now we removed B. Here we remove A because A has no incoming edges, right? Now
Hmm.
because A is removed, we remove all these three, right? Because A is removed. Now because A is removed, from that A and D would go because they have no incoming edges.
Yeah.
Correct. Now let's just go back to this. Does everything have an outgoing edge? Yes. Does everything have an incoming edge? Yes. Does everything have an incoming edge? Yes. Damn, this was a lot
No,
easier.
you have to remove the B also from Y because achha, only incoming you are checking at present.
Oh
Okay,
yeah, this
fine.
has no outgoing edges.
Yeah, no outgoing edge.
So this needs to go. And because that, these two need to go. And now because C needs to go.
Yes.
Right? And if they're in outgoing edges, yes. If they're outgoing edges, yes. If they're incoming edges, yes. Sorry, if they're incoming outgoing, yes. And if they're incoming, yes. Okay. Now this is the final form.
Yeah.
Okay, carry a pencil and eraser. I'll just write it here. Pencil eraser.
Going to go nuts in exam actually.
Yeah. Okay, so this is the final form.
Yeah.
Hmm, that's why I was trying to see whether it's possible with the sec notation, but I think it's just too recursive
Too
there.
confusing actually with sets.
That it just
Means
if
of course you can track the steps, but otherwise it's too
you
confusing.
might miss. That's the problem.
Hmm.
So after making R consistent, so it is A and D here. Dy is C and D, and dz is B and C. Okay, cool. I think that was worth spending half an hour or whatever time we spent. Line drawings. This one. How much time it's? Ooh, wow! It's already like 1.5 hours. Okay, we are barely into. We just covered like 10 questions. Huh. Should we increase the pace or is it too slow?
I'm okay with increasing the pace, but yeah,
Okay, the
just,
valid junctions this that occur in 2D line drawings of this are given. These junctions provide constraints on the possible edge assignments, convex, concave, and arrow. The junctions are assigned unique labels L1 to okay, L1 to L6, T1 to T4, and W1 to W3, Y1 to Y3. Okay, and moveGen function allows the above order, and use the above order to break the ties. Okay, so there are any ties, break using this order, and enter these junction labels in short answers. Okay, I think too much zoomed in for this. The function, the figure below. I am dyslexic, I think. The figure below is a 2D line drawing of 3D trihedral objects. A hollow block which is hollowed out from the top, front and right sides and is resting on a solid block. Okay, and something like that. Let's just open that. Use the knowledge about 3D objects to determine the edge labels and use those edge labels to determine the junction labels for all vertices in the 2D drawing. If an edge or a junction cannot be assigned a valid label, its label is nil. If the multiple valid labels are applicable, then select a label of your choice. Okay, so what is the junction label of vertex 1? Vertex 1 being this one. I'll copy this. Wait.
Which letter?
Yeah. So vertex 1. This one. So this one's a W junction. We are talking about this. What's the junction given here? Okay, these are the junction labels, right?
I think they are asking specific W.
Yes, they are asking from this. So, vertex 1 has what? So can we label the edges for this? So what is edge 2? What is edge, what is this edge? What is this edge? What is this edge? That's what we need to know, and because of that we'd be able to answer what W1 is. Okay, how can we think about this?
Sir, one thing, this image is easily comprehensible by humans, no?
Yeah,
Even though it's on paper, we can comprehend easily, right?
yeah,
With that information, if you see one and two edge,
this one.
yeah, material is on the left side, no?
So this arrow should be done.
Like that, we can easily make.
So for this it should be this.
Yes, and
For this it should be
1 3 is Material is inside 270 degree. It should be minus, no?
Mm,
I think so, yeah.
so this should be a concave edge. That's what I was wondering too. But
Yeah,
I
but
forgot
there is
how
no
to.
W.
Yeah, I forgot how to add the angle thing here though. Okay, no, I got it. So this is the 90-degree angle that we are looking for, right?
Hmm.
This is the 90-degree angle we are looking for, and because this 90-degree angle is a hollow part, then that means this is a concave edge.
But there is no such W.
But there is no, yeah, exactly. There is no such thing over there.
Where?
In the given W1, W2, W3,
Uh,
whatever is with arrows at the side edges, it has plus inside. There is no minus
so there's
because
no
whatever is has
arrow.
minus,
This one?
it is plus over
This
there.
one's
No,
a
that's Y junction.
yeah.
That's not W.
Uh, so it can't be. I mean, I'm not sure whether this is concave. I think the logic is fine that it should be concave though, because this angle is 90-degree and this angle is hollow, right?
We can take change the arrows opposite way and make it less.
Shall I suggest something?
Yeah.
Yes, yes.
Start with vertex 16. It is a T junction. That
Okay.
will make it easier to then trace other vertices.
Right. This is a T junction. Yeah.
Hmm.
So because
Okay.
of this, if we are talking about this thing,
So look at the upper part of the T. Matter is on the right side.
yeah.
So all the arrows are there, and negative, yeah, and negative
For this.
vertical line.
Yeah. Because of
And
this
then
angle.
we should, yeah, and let's then trace other vertices to
Okay.
ensure consistency.
That makes sense. So firstly, we need
Then
to label
one
the
can be
entire
W3.
thing.
If we make minus already from the
Yeah.
T, W3 will come at 1.
No, but why are these positive? That's now the thing. And I believe they are positive because I literally forgot
But
the
Sujay,
analogy I made.
Sujay, we cannot necessarily say that W3 will come at that junction. And in this case, it is possible, but with just looking at the model, it would be difficult to say because we do not know if there is a layer beneath that. We cannot, it's not visible to our eyes. So it could vary also. So only, I mean, I understood from, working these kind of problems that only way to go is just try taking one vertex after other and match the consistencies.
So if we talk about this edge, what is this?
19 or 12. 19 is a W.
No, no, no. I'm talking about this edge, this thing. Is it positive? Is it negative? Is it an arrow? What is it? I think it should be just like if we talk about a box
Huh?
like this.
Like positive, but
It should be positive, yeah.
Yeah. So if I'm talking about this thing here, then this angle is 90 degrees, right? And because of that, this is a convex edge. So if we take about this, we think about this here. Okay, so if we talk about this one, between 11 and 12, this long one, right? So is this an arrow? It's not.
I think that is only because material that we cannot say now, like
It
Shaival
should be
told.
this arrow. Material is to the right.
Right, no? So no, the arrow should be the other way, right?
Yeah. So
But it is to
material
the right.
the right here.
Oh, that way. I'm talking about the inside material.
That's what's confusing me too.
no, it should be on the same surface. Huh? Inside material is a different surface
Okay.
on the
Okay.
same side.
Like if we talk about this
Hmm,
here,
surface meaning?
then that just my interpretation for an arrow is that there's a plane along this side.
Yeah, It should be a plane along that
My
side.
interpretation of of a convex surface is that I can draw a 90-degree angle here, and the material is inside this 90-degree angle.
Right.
And my interpretation of a concave edge is that I can draw a 90-degree angle here, such a way that the material is in the 270-degree angle.
That also makes sense. Yeah.
So if we try to add those interpretations here, if we go over this again, just let's start from scratch. So Shahwal firstly said that let's talk about this one, this long thing, right? So this long thing is a negative edge because we can see that the 90-degree angle leads to an open space. So this is negative, okay? If we're talking about 18 to 19, this long thing, I believe there should be a right arrow because the plane is to the right of this,
Correct.
correct? So if I go over this again, then this should also be something like this.
Ishan, no, it will not be an arrow because it makes an angle with the block below. So this will be a minus
Right,
edge.
right. I forgot there's a block below.
It should be plus, no? Material is
No,
90
it should
degree.
be minus.
Oh yeah. Right. It should be minus.
It should be minus because of this. There's
Yeah.
there's a
Yeah.
negative space here.
The material is
Yes.
270 degree.
Yeah, material is in the 270 degree.
Okay.
Mm.
I was completely ignoring this large thing down there.
Okay.
So
Okay.
this is a arrow, this is an arrow, this is an arrow. No, this is plus. This is minus, right? This is also minus. This is an arrow.
Ishan, Ish-
Okay,
Ishan, one suggestion.
let's do that
Don't
step by
don't
step.
go don't go by just putting arrows because when
Yeah.
you start putting the consistencies, it could become plus or minus
Yeah.
also.
Yeah.
Yeah. True.
16 was a safer bet to start,
It's a safe bet,
and
Yes.
then
okay.
19, 20, those are
19
negative
and
edges.
20, these two are also negative edges. Okay.
And then 10 to 16 and 16 to 15, you can put the arrows which are going towards 10.
Yeah, in such a way. Yeah.
So this
So
will
here
become
as
16
well.
is 4. So at 16, you write T4.
16 would be T4. Yes, correct this one. I'm trying to find out. Okay, so why were you saying that an arrow here is not a good idea?
Where
Here.
there is a possibility that while you're trying to match the consistency, there could be a plus sign also because you do not see basically whenever the entire exercise is to identify model or part of the model, so it is not necessarily um, the situation where you will be given the entire model. So we need to even identify with part of the model. There is a possibility that there could be another block sitting below this which is not given, so you don't know
Yeah.
before you be decide on that. And also in the lecture they mentioned angle of the picture that is provided to us. To our naked eyes we feel that this is the angle and we assume that this is how it should be, but actually it could be something else. The angle, that is, if we change the angle of the model, you can see substance somewhere else too.
Yeah, okay, so something like this maybe. And if I draw another thing outwards. Okay, leave this.
Now if you solve, say, vertex 15 or junction 15, that will necessarily be W1
Mm, okay,
Because of arrow.
because of arrow.
okay. So your suggestion is to start with more consistent junctions like the T junction here.
Yeah,
Okay.
The
that's the
order is
easiest.
TWYL.
Sorry?
TWYL. This is the knowledge with reasoning. TWYL. The order should be better if you want faster solution.
So T W Y L.
L.
We start with a
Because
T junction. Okay.
the reason is in the T junction there are 4 labels T1, T2, T3, T4. all horizontal are same.
TWIL. No, I don't get why.
The first label to test is T, because T1, T2, T3, T4 is having
Right. This thing.
commonality in the horizontal.
Yeah.
Then going for WO because of just three labels.
Okay. But also
Then
Y
Y.
also has three labels. But okay.
But in the diagram, mostly W will occur more than Y, right? Can you say like that? Not
Yeah.
necessarily. Okay.
Yeah. This is a W. This is a W. This is a W. Sorry, no, that's a Y. This is a W, and this
So
is a
that
W.
reason is not correct, I think. But why L is last? Because there are six, no? We can
Yeah, there's a
do a
lot of variation there. Okay, so let's try to follow this thing. Okay, TWIL. So, firstly, there's the T junction here, this one. And so this is a negative edge. This is a right arrow because the material is to the right, and this is a right arrow because the material is to the right. If we try to find any other T junction, I don't think we'll find any like that, because it needs a line, and because it needs something like this. Okay, so that's the only one. The next one we can see are the W junctions, if we are going by this order, TWYL. So W is this, then there's this, then there's this, then there's this, and this. Okay, there's 7 such W junctions. Okay, I think one safe assumption we can make is that because we don't see anything below this gray box, we can say that this is an arrow, right? Because the surface does not make any angle and the material is to the right. Am I correct about that?
Not necessarily.
Yeah, but it can change going forward, and if it does, we can just
Yeah,
update that.
yeah, okay.
Okay.
But the way to go now is take something in connection to the T junction that you've identified. So it's like, trying to fix a jigsaw puzzle.
Okay, wait, please wait. I remember this video that I was trying to think about. Yeah, the Waltz algorithm. So how does this solve? David Waltz extended the domain defined by Huffman more than 3 edge vertices of which it tracks. The number of edges shot up to, I'm not sure what this means. Okay, so it firstly assumes that everything is a right arrow. Or maybe let's watch that lecture itself that goes over. Damn.
Example, then you can see complexity of AC3. AC3 is, remember, EK cube essentially. AC4 is EK square essentially, but we do not have time to discuss those algorithms. Vertices is the number of possible, as
So here he shows an algorithm which solves these kinds of problems.
so there's an add. Skip the add. So here is the algorithm, as you can see. It's starting, and what it will show at the vertices is the number of possible combinations left essentially. So now it is about to start essentially. This was done in the 70s and the 80s. So here, you can read some text at the bottom if you do that, you will see that there are some impossible combinations. So now this is where the propagation takes place essentially, that from one vertex to another essentially. It's a 2-minute video, so we'll just watch it through. So here is a figure that they are trying to label. You can see that there are some shadows, which of the triangular block has a shadow which is falling on the rectangular block, and the rectangular block also has a shadow which is falling on the table or the floor, whatever the case may be. The numbers that you can see, if you can read this, is the number of vertex combinations that are allowed essentially. So there's an L vertex on the left, and there's a W vertex on the right, and it is basically propagating constraints between them, and you can see that the number of combinations is decreasing essentially. And then of course it propagates then to other vertices also which are connected to them. So you can see that it's vertex to vertex propagation, that from any vertex you try and propagate the constraints to the connected vertex, and it is doing that. As you can see, the numbers on the left hand side have come down.
So we can see that the arrows are being, what can I say, the labels are being marked as arrows first here, and especially it's the ones that are on the base itself, like this one, this one, this one, this one. So now this algorithm in particular started off with these two edges because they were the ones projecting a shadow on this block here, and then it figured out some count on these two edges, and using constraint processing it somehow decreased those counts, and once it was decreased enough it started processing them, and from there on it started inferring that okay, this is an arrow, this is an arrow edge, this is a convex edge, this is a concave edge, and so on. So for this thing itself, should we, that's why I'm saying that I think it will be a good idea to just start off with this. Like, we are humans, we know that there is no block beneath this, like we don't need to mark this, we can't mark this as a right edge because we know that there is a block here and it's making a 90-degree angle width. So we know that because it's making a 90-degree angle with this here, this needs to be a concave edge, this needs to be a concave edge, right? But because we know that there's no block down there, we can just simply assume that yeah, these are just right edges. Is that fine? Let me again see more here. Yeah, so we can just simply make this assumption that these are just right arrows. Simple enough. Okay, we can't make the same assumption here because these are not base edges, these are edges that act in this way. Okay, and again we can see that it forms a 90-degree angle in such a way that the material is on the inside of this 90-degree angle. So this edge needs to be a positive edge, convex edge, and so does this edge needs to be a convex edge. That makes sense?
Yes.
So I believe even this edge is a convex edge, or is it? Or is it something like this?
Yes, arrow.
Arrow, because we cannot see it make that 90-degree angle, right? Us as humans know that it's going down and it's going this way and then it's going downwards, and this downwards is hidden, and this is a so this should be a convex edge, but because we can't see that here, we just mark this as an arrow like this, that to the right there's the surface. So similar we can do that here. Is that fine, Shehbal?
Yeah, and edge 24 to 28, the arrow will be other side.
Edge
To
24
make it
to
consistent.
edge 24 to 20.
20, 28.
Oh, 28. Oh, right, sorry. I drew that wrong. Yeah. This way. Okay. So let's just assume that the base is clear. That now we have basically marked. Okay, now this remains. Okay, now this thing remains. So what does this thing do? So this is not a right edge, right? I'm calling the arrow edges as right edges. So this is not a right edge because there's no material to the right. This should be, because I can make, because I am assuming that this is on the I am assuming that
That
this
is
is on
W.
the itself, right?
Already W, no?
No, it is a W junction, that is correct, but what is this edge? Is
It
it?
looks like a plus.
Yeah, there's
Plus
because
because
yeah, it looks like a plus
yeah,
because there's
two
only
arrow.
this plus allowed here, right? So we can mark this as plus. Let's just check this here. Yeah, but why is this a plus?
Convex.
Oh, right. It is because of this. Yeah,
Yes.
because of this right angle. I was too much focusing on these right angles. Yeah. So because of that right angle, this is a convex edge. Okay. Now I believe all the edges for this gray box are covered. Yeah. Okay. That's cool. Now we can move on to the green one. Let's just remove these for the sake of doing them step by step. So we know because of this right angle that and this right angle that these two are concave edges because their right angle points towards an empty space. What about these? What? Okay, no. What about this thing? This one, this bad boy.
That is T.
That is, I like to say that's a T. Yeah, it is a T junction because of this thing, right? And because of so again, these two should be an arrow.
Yeah, T1.
Yeah. Okay, the same logic applies from this. Uh, Maybe now we should ignore this for now because we should not be coming to conclusions uh, because this says so, right? Maybe we should try and come up with logic on why this is a right edge. Like, sure, because this is a T junction, and T junctions can be of only these three forms. But I think a better way is to think of this like because we are marking this as a right edge, and this is a similar kind of edge. This is a right edge. Is that fine? Is that fine of a logic? Because there is material to the right and there is no angle being formed at this edge. Okay? Similar to this, because I don't think there is an angle being formed at this edge, because sure there is this face to the behind of it, but we can't see that, so there is no angle being formed, and that's why it's like this. So again, this edge should be this edge should be a right edge as well, 7 6, because I can't see any angle being formed there. Okay. Similarly, this should be a right edge. These can't be a right edge because I can see a 90-degree angle being formed here. Okay, I think I cracked it now. Does this make sense so far, that why I marked these as right edges?
Yeah.
Yeah.
Yeah, but these aren't right edges because I can identify a right angle here, right? Because I know that there's a right angle here. These are positive edges because those right angles point towards the material. Okay, so I just had a aha moment. I'll write that down maybe. So right angle means material to the right.
Plus means 90-degree material.
Yeah. Plus means material inside
90-degree.
90-degree or right angle.
270 is also right angle, no?
Is it? It is.
No. Okay, 90. Okay. Right angle is 90.
Now I have to search that. Is 270 also a right angle? No, maybe burn that OpenAI money asking these kind of questions. A right angle is exactly 90. Okay, 270 can't be a right angle. Okay. Okay. New
That's
thing.
reflex.
Yeah, two right angled, and and this means material is outside right angle. Another thing to note here is that don't use your brain, don't try to infer faces that you can't see. So don't use brain to infer faces you can't see and angles you can't see. Right? Because sure there is an angle being formed here, but we are not supposed to infer that, because as a, what can I say, a computer vision model won't know that this is a box and there's a hidden face to that side, right? That's why we too must not do that, and that's it. So this is a positive edge, this is a positive edge. Okay. What is this? This is a right edge, right? Because sure I can again infer an angle like that, but I don't see that angle. So this is a right edge, something like this. Am I correct? Similarly, this is a right edge. Similarly, these are positive edges, right? Positive.
Why?
Positive because of this right angle.
Okay.
Because this right angle encompasses the material, right? So
Mm-hmm.
these are
Right.
positive. Now this 1 3, what is that thing? Okay, yeah, no, that thing is we see this right angle, right?
So it should be negative.
Yeah, it should be negative because this right angle is encompassing a negative area. Okay.
Mm.
So now we come to 10 to 15. No, we come to 10 to 6. So 10 to 6, again I don't see any angles, so I'll just write it like this. Again 16 to 15, I don't see any angles, so I'll just write this like this. 18 to 14, 18 to 14, this edge, I don't see any angles, so I'll just write it like this. Are there any angles between this? 15 to 14, not 18 to 14. Are there any angles here? There are none, right? So I'll just write it like this. 8 to 15, I see this angle, right? And this angle is encompassing a 90-degree angle. Sorry, this angle is encompassing the material around this edge. So I'll mark it as a positive edge. Now let's just come to 11 to 12. 11 to 12, I can see this. So again, a positive edge, a positive edge. A 10 to 11, I don't see, okay, no, I do see this angle, yeah, I forgot, yeah, there is this angle, so this is also a positive edge. Okay. 11 to 17, I see this angle and this angle is empty, so this is a negative edge. Similarly, 17 to 13 is a negative edge. Okay, this thing remains. Where 16 to 17, and here I see this, where the 90-degree points to a negative space, so this is a negative edge. Is that
Yeah.
fine?
13 to 14 is also remaining.
13 to 14 is okay, yeah, 13 to 14 is remaining. I see this angle, so that's a positive edge.
Okay.
Okay,
Okay.
that's fine.
Mm-hmm.
So we don't need any ordering as well. We just need to keep in mind whether we see that angle or not. In all
What will
these,
be
yeah,
what will be edge 9 to 20?
yeah, I would have definitely missed some edges. 9 to 20.
Oh yeah, even 9 to 20, yes.
9 to 20. This.
And there is a T at 25.
Okay, 9 to 20, there is no angle. No. 9 to 20 can't be an edge. 9 to 25 would be, and 25 to 20 would be, right? So these two would be this.
Hmm.
Yeah, because I don't see any angle
Yeah.
there. Like sure,
Right.
that you can infer an angle there, but you can't see from this viewpoint.
Mm-hmm.
Am I missing anything else? No?
Not that I can think of.
Okay, after like when we try to label any vertices, label the vertices, we'll definitely figure that out, I think.
Yeah.
Okay, now let's try to label the vertices. I should maybe move this down. Okay, I think that's good one. Did everyone understand, or should I do that whole thing again?
Got it.
Got it,
Yeah,
right?
got it.
Okay, so what was the question asking now? Okay, what is V1? V1, this thing, right? So this thing we can see it's a W junction with positive, negative, positive. So is there a W with positive, negative,
It's
positive? Yes,
W3.
there is
W3. Yeah.
this, right? W3. So this
Yeah.
is a W3. W3. It doesn't satisfy anything else, right? Only W3 because it's only a W junction there.
Mm-hmm.
Yeah, W3.
Yeah.
What is vertex 7? Vertex 7 is this one, right? So it's also a W junction with arrow plus arrow.
W1.
Arrow
W1.
plus arrow, W1. W3 is W1. W1. Cool. Then vertex
Cool.
19. Vertex 19 is right here. Right, we did not mark this edge. Okay, let's see. So this is
Yeah.
a positive edge, so it must be
Positive.
positive,
Yeah.
right? So
Minus,
negative
minus,
plus
minus.
negative. W2.
W2.
Damn, now I think we nailed that logic, right? W19 is W2. W2. Yeah.
Cool.
Vertex 2. Vertex 2, vertex 4, of course, ask everything. Vertex 2 is this, right?
L.
It's an L edge, L junction with negative arrow. Sorry, positive and arrow. Positive and arrow is
L6.
this one.
L6, no? Outgoing. Arrow is outgoing.
Okay, right. Yeah, L6. We have a plus and an outgoing, so W2 is L6. Cool.
Cool.
And then W4 is W4. Let's just write W4, W6, W17,
So L4, I think.
W23. Okay, so what is W4 here? W4 is this one. So incoming arrow,
L4.
outgoing arrow. Incoming arrow, outgoing arrow. So there's these
L4,
two,
no?
but which
Oh.
one would apply?
I think L4 will apply to that.
Yes, because this one is this one should be an incoming arrow. This, right?
Mm-hmm.
So L4.
Yeah.
L4. V6.
Six
V6
is
is
where-
this one. Incoming arrow, outgoing arrow. So it's also an L junction. And I can
think it's
maybe
L1.
rotate that in this way, like it's this, right?
I think it's L1.
It's this, and if I try to rotate this, let me try and overcomplicate, How do I rotate? Is there no rotating option? Okay, no, there is.
This is that
Like
thing.
this. Good.
L1.
L1. Yeah, L1, then V17, it's a negative, negative, negative. Negative, 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 and it's a Y junction, I think.
Y2, yeah.
This one.
Y2. Mm-hmm.
Then W23 is this one, which is a negative plus 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 Y
Plus,
junction.
plus,
This
plus.
one,
Yeah. Y3.
Y3. So L4,
L4, L1, Y2, Y3.
L4, L1,
Y2, Y3.
Then there's 16, 21, 25. Okay. I think now this became trivial, right? 16, 21, 25. There's another one for line. What is this line drawing, right? So we
It's only lane drawing.
16 is
T
T4.
junction, arrow, negative arrow. So T junction, arrow, negative
T4,
arrow. Yeah, this
T4.
one. T4.
21 is
21 is this thing. It's also a T junction with full arrows.
inside
So-
T1.
So left going arrows and then an arrow coming to them. This one.
Yeah.
And
25.
25 is this one.
T2.
Yeah, T2. T4, T1, T2. T4, T1, T2. Let's submit. All correct.
Wow. Cool.
So we figured that out. There's another one. Let's
Yeah.
try.
But Ishan, in this, the second case, how will you find out? Because there is no three-dimensional figure over there.
There is no
Yeah.
need for a 3 dimension, I think. Because here too we did not think of it in 3D, right? Here
No, we
were-
were thinking 90 degrees angle and all that stuff, right?
I won't say that is 3D, right?
I mean, how will you apply to that?
Okay, let's see. Hopefully we are able to, otherwise that will be a big worry. Okay, let's just copy this again. I wanted to do week 9, but damn, this is taking too long. Okay, L1, L2, L3 and blah 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 blah. And what is this junction? What is this junction? So
This
that's
is
a
anyway
T
Y.
junction, right?
Oh, sorry, T junction, not Y. Yeah,
So
T
one is
junction.
a T junction. Okay, I'll draw this. I know. Maybe I know. Okay. So material is to the right, this way. Okay. So something like this.
Okay.
Huh.
No, Ishan, arrow should be opposite.
Arrow should be opposite.
Yes, because if you rotate the T on the paper,
Okay. Whatever has been given, as per that, there is no T with. No, there is T with left arrow
There
also.
are T1 and T2, both are opposite positions.
Yeah. There are.
And I'm not going by this. I'm just trying.
But
to
if you put that arrow over there, Ishan, the second one for that material is on left. So over that, how will you place the arrow positions over there?
That is true. Something like this, maybe.
Yeah, but still that question is unsolved, no?
No, this can be possible. Where,
How
right? This
No.
can be possible.
no T
That
is possible.
It won't be possible.
if we go by what is considered as the material, then the for second it is contradictory, no?
Yeah.
Now for first it is contradictory.
This. See, now this thing satisfies T1 perfectly. Okay.
That is okay.
But
The
we
other one,
force
how will you?
that to satisfy.
Arrows will contradict here because both of them are the opposite side.
Yeah. We
Yes.
can't do that here. That these three can't be together. But this is a T junction.
Yeah, both of them are T junctions.
there is no angle.
Hmm.
That was how we were trying.
What is the answer over there actually?
Let's see. Nil.
Nil.
Of course, there's
Oh, because we couldn't place it. Okay.
Okay, so that's also possible.
Yeah.
Okay. Okay. So if I assume that the material is to the right, okay, something like that,
Hmm.
then what would happen is that no, this is not possible.
No. If you consider where your material is to the right
Yeah,
and
this is
draw the
possible.
arrows, the third arrow is in the opposite direction, which is not possible. That's
Yeah.
why it's nil.
So see, we don't even need to consider these arrows, okay? So we just think that okay, material is to the right in this one, right? And this can be either
Mhm.
this or it can be this, both are fine. But if we
Yeah.
go ahead and if we consider this also as a T junction,
Hmm.
if we say the material is to the right, then how can it be to the
Mhm.
right if it's a T junction? Right?
Yeah.
Because it's usually something
Right.
like this.
Hmm.
Let's just try and come up with a counter example, maybe. So this is a valid T junction, I suppose. This thing.
Hmm.
So the material is to the right, and you saying this, right? If you were
Hmm.
to say this, that the material is to this side, then you would have something like that. And now, is that still a T junction? It is. It is a T junction. This is still a T junction. These two.
Yeah.
Hmm. I'm not sure about this. All the confidence I got from the previous one is gone.
No, even I got stuck in GA on these things. That one, of course, I got partially right, partially wrong. But I got stuck on this. How will we find out the material thing over here?
Huh.
It's a 2D
So
picture.
no, like we said that. Okay.
No, but for this nail, I understood why it's coming
Yeah,
because
because it contradicts.
it's a contradictory.
Because if
Huh.
this is this, right?
Yeah.
If for this to be a T junction, the arrow should be this, right? And
Yeah.
here there's a
Right.
contradiction. So that way we can
Yes.
solve that. Okay, this is a nil.
That is nail. Next one is challenging.
Okay. Watch me fail then. This one.
You're traveling in the same boat here.
This one. Like I don't have confidence at all. Okay, so this is a W, this is a T, right?
Hmm.
So again, I have to mark
We consider
this
T
as
and
this
T
direction, right? Because that's a
material.
T junction. T junction
Yeah.
will only have this, and this can be anything. I'll just mark this as X. It's don't care. We
Mhm.
don't care what that is. So now, if we're talking about W junctions, there is no W which takes in an arrow.
We consider T and then that slanting thing, consider it as the material on the right, and then we have to do it. I think so.
Like, is nil also the
Suggestion
answer
is
for this?
when
Yeah,
hello,
we
my
can check the
suggestion
Yeah,
is
it
answer.
is a nil. And
Hey,
my
this is
logic,
also nil. What
yeah,
the
my
hell?
logic is this. That, see, this is unanimously a T junction, this is unanimously a double junction, right?
Yeah.
Now, T junctions have something in common, that all of those have this arrow. And the
Oh,
arrows need
left
to be
arrow.
pointing in
only.
this direction only for
Oh,
this to
okay,
be
okay,
valid.
okay, okay. Right.
But now,
Right,
if
right.
this is an arrow, then
Hmm.
there is no W junction whose middle edge is an arrow.
Yeah, right.
And because of that, this is nil.
in this kind of diagram, don't think in terms of material.
Yeah,
Exactly.
think in terms of this itself.
Yeah, right. Just try which one is fitting properly.
Yes. Like in the previous one, it was nice that we had the entire material, but now we can't.
Hmm.
Contradict. This one now.
Okay.
So I think this is just logical reasoning now. But
Yes.
can you find a pattern? So see again, now this is a T junction, and because that's a T junction, the arrows need to point this way. This is a don't care,
Yes.
right? Now that's a T junction. These two are W junctions. Okay.
W junctions.
Now,
Yes.
is there a W junction that takes in an arrow? Yes, there is. There's
Inside, yeah, W1 is there.
Yeah, there's this one, and so okay. So if I were to draw it like this, then the arrow
Yeah,
is
try putting the
coming
arrows over there itself,
there.
now in
Yeah.
the diagram.
So it would go here, meaning that this would go in the opposite direction.
Yes.
This is again a
Yes.
don't care, that I don't care what that is, and because of that, this can again also go this way, right?
Yeah,
No, it
but
can't. It can't. It
that
can't.
is opposite.
Can't.
That is
Yes.
opposite.
So
So again,
that
it
is
should be
opposite.
nil.
And this should be this, so again contradicts.
Yes.
Nil. Okay, thank God, nil.
Yeah, right.
So
Okay.
this junction.
This one. There are two T's.
So see again, T junction is there. T junction.
Yes.
So something like this needs to be there, right? And this is a
This
don't
should be
care. This is a don't care. No, sorry. Not this.
uh,
This is
हाँ,
an
opposite, opposite. Yeah, yeah.
this.
Hmm.
This is a don't care.
Right.
This is a don't care.
Hmm.
And this is something like, right? But here we can't make it a don't care, but we need to care about that because this is a Y junction.
Yeah.
Now, is there
Now
a
plus
Y
or minus
junction?
Plus,
So,
plus, plus or minus, minus, minus.
or arrows.
or arrows. Yeah, yeah, yeah.
Yeah.
If it goes, if it
But
is.
this is a Y junction,
and
and Y junction, if we talk about this, then it either both are arrows, either both are negative, or either both are positive. Yes, that's what suggestion. Yeah. So can both be negative?
No, with arrows it cannot go because the arrows are contradictory for y1. So it cannot
No,
go
no,
with
it's,
that.
it's valid.
Yeah, that's
Arrows
what I
is
was,
also
No, it is
because
actually
see,
this
Oh,
will take
P2 as well.
this will
Okay,
take
then P2 as
multiple
well.
values.
yeah,
Yeah,
if
multiple
we talk
assignments.
about arrows, then arrows can be like this as well, right?
No, that is
Not
that is
like
They
contradictory
can be
arrow.
like this as well,
It should be the other way.
and they can be like this as well, right?
Yes.
Because all possible
This
combinations.
will work.
Yeah, because
This
see,
will work.
because the arrow here if doesn't matter what direction it is, right? So if I were to forcibly try to make this a y1 junction, I can easily do that, right? Yeah, this is possible, right?
Yeah.
I can similarly do it like this as well, right? Yeah, both can be negative. That's
Yes.
fine. Both can be positive. That's also fine. Okay. So if we were
Yeah.
to
For
make
1
that,
and 3 is fixed.
so y1, y2, y3, all three are possible.
Yes.
Okay.
What is the question over there?
Yeah, let me just write it y1, y2, y3. Because it can be positive,
Table
Yeah.
1.
it can be negative, it can be an arrow.
Yes.
What is the label junction? Now,
Vertex
so
1.
that-
Oh. Vertex 1.
don't
Vertex
think
1
about
is
that's a T
something.
junction.
Yes.
That's a
Which
T
one is
junction.
that
T1,
T1? No, but
There's
T1
an
or-
order given here that T1 needs to be prioritized because it can be.
oh, okay. Okay.
Because if we are talking about just a T1 junction, there is no contradiction. Okay, so
Hmm.
what if T1 was fine, this is completely fine, and there's a contradiction on the right hand side? So would we still say that this is a T junction, T1 junction?
I don't think so.
Why?
Because the entire
We are talking about this vertex only. Sure, it is not a valid shape. It's not a valid trihedral, but this junction is valid, right? It's
aren't
not
we
like
supposed to
I can-
solve the entire thing and then decide? Because they check the question because they generally say that solve that and then do it.
T1,
Just
T2,
check.
T3, T4, that's fine.
All T's are possible.
Yeah, okay. Yeah, all T's are possible. This is a don't
Yeah.
care, right?
Sujay, that is when we said multiple assignments possible, no?
This is a don't care. The thing that I've been doing so
That is
far.
don't care. But to make consistent all three,
Yes, that's why I asked this question, that if this vertex is fine, but there's a contradiction on the rest of the shape, so I
Okay,
think
go
this
to the
vertex should be
question.
still labeled as T1,
Go to
T2,
the
T3.
question. Just check whether there are the for the earlier ones, which
Oh damn it. Okay, I accidentally misclicked and got out of the meeting.
last year.
Yeah, instead of switching the slides, I accidentally closed the Google Meet.
okay, just check the earlier question. Which vertex they had asked for the contradictory things.
Vertex 1.
The other one, yeah, the
Vertex 1.
upper ones. Vertex one, na. So I think the vertex one we could have assigned over here, na, if I'm not wrong, or no.
No, we couldn't have.
See, we had given that, no.
Mm,
But the entire figure was not solvable. That's why it was written nil, right?
no, I
Vertex
think
one was
we can't
solvable.
solve this, right?
Okay, just check the third one. The T1 T junction and two W's, where you have written contradiction in the black thing.
Oh, right.
That one, first one was solvable. That vertex one, see?
Yeah, I forgot that.
Yeah.
We should
But
think
the entire
complete diagram and answer
yeah,
particular level.
because I do remember the top one where it was 3D. They had written that solve the complete thing and then start assigning the vertices.
Got it.
So
Got
I
it.
think if it's the entire thing is
So
solvable, then only we are supposed to.
Yeah,
in
this.
fourth diagram,
Yeah.
label 1 cannot have T1. It will be inconsistent.
How?
Yeah, it cannot because Y के लिए those arrows are not possible present. See?
Yeah, it
No,
won't
they
match
are. This one.
table with the Y. Yeah, that is possible.
But that is
But,
not T1, na? That is T2.
That is T2. T1 is not possible.
No,
For
I
the
can
vertex
make
one.
this too, right? Let me try and convince you. So
Okay.
I am doing this. So
Hmm.
these arrow point towards each other, right?
No such Y.
No.
No,
See.
I'm doing this. Wait.
Okay.
And negative, and then I just rotate this. Possible?
See? Eh?
Possible?
एक मिनट क्या
Yeah,
किया
let
था?
me show. I mark this as this. I mark this as this.
Right.
I mark this as this.
Uh.
Right? This is a don't care. We don't care what this is.
Yeah.
Negative is possible here because this is a TH, right?
Mm-hmm.
And an arrow like this is possible here because because we can get it from T1, right?
Oh, the
Now, if I
other
rotate
stripe
this
wala
entire
Y.
thing,
Okay. Got
doesn't
it.
match Y1
Yes.
itself?
Oh, okay,
yeah.
Ishan. Got it.
Oh.
Good observation.
I didn't observe that.
We missed that rotation.
Yeah.
Yes.
This is not the only Y. This is also a Y, right?
yes. Right.
Then everything is consistent.
Yeah, that's why I said that
Mhm.
T1, T2, T3, T4 are all possible.
Nice.
But it is unanimously accepted now that if the figure is solvable, then only we have to go for the vertex.
Yes.
Yeah.
Otherwise,
We have to
that's
complete
right,
diagram.
no?
Yeah, that's
Okay.
clear. So T1, T2, T3, T4. What is the junction in this?
Here is one T.
Yeah, we should always start with a T, I think.
Yeah.
Because there's this, and so arrow should be like
Then
this.
one Y, one L, and one W.
Wait,
Okay.
the arrow should be like this, firstly. Yeah? No.
No, it's an opposite.
The arrow should be
No, opposite.
way. Sure. Yeah, the arrow should be the opposite way, this way. Okay? There won't be the ability to rotate in the exam, that's why I have to take my own head.
Exactly. We
No, I
have
can
to
just-
use
no, I can just
use
rotate
our
the-
imagination.
No, I can just rotate the copy itself, right? yeah, this makes sense.
Yeah, that we can do.
I'll just read the answer. So this, yeah. Now next is, what is this? This can be anything. This can
Anything,
be
yeah,
anything
don't
is
care.
fine. We don't care. This is don't care. Anything is fine. What is it asking? Whatever it be asking, firstly we need to find that whether this is consistent or not.
Yeah, exactly.
So this is an
Then
L edge, right? L junction. This L junction has an incoming edge, so this should have an outgoing edge because L4. Or it
yeah,
can be plus.
right.
Or it can be plus. Both are fine.
Oh yeah, right, right.
Okay?
So if it is plus, so it
So
should be either arrows or minus.
no. Now see this. That the W junction never has an
Yeah,
arrow in the middle. So
yes.
No arrow.
arrow is not
No,
possible,
so
only a
it should
plus
be
is
plus only.
possible. And if only a plus is possible,
Hmm.
these are either now what direction they are. They are, see, this one is pointing towards the center, and this one is this. So something like this,
Yes, correct.
right? So either this or either
Hmm.
this are negative edge, right?
Yeah, yeah.
So only those are possible. Write them better.
We have to match with the one.
Yeah. Now we have to match this with 1. Now for 1, we can see that y
Yes,
can
Either minus,
take
minus, minus,
even the arrow
minus, minus,
or
minus,
even
or
this, right? So both are fine. Both y1 and y2 are fine because this
Yes.
can be either this or negative edge.
Yeah.
This I don't care, so it can satisfy anything.
Hmm.
So this satisfies y1 or y2.
Yeah. So vertex 4.
Oh
Vertex
right, so
4 is
why am
what?
I labeling that then? Vertex 4 is anything then.
Yeah.
T1, T2, T3, T4. Why a T4?
Ah, 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 ah.
Oh, okay, sorry,
have to complete.
yeah. Exactly a T4, yeah.
Oh yeah. Minus.
Because this thing is a
Minus ही
y1
होगा
or
बराबर है.
y2.
It should be
Yeah,
minus.
this,
Yeah.
this needs to be a minus.
Hmm.
Because these two again.
Oh my god.
So T4.
Hmm.
Okay. So we still have a way of solving these. It's not difficult. Like I
Not
just
difficult, but our senses should be in place for that.
Yeah,
If
like
we miss something, then we are gone.
I'm saying it's not difficult right after making a blunder, but it's not difficult. Okay, this
It's
one
not
again.
impossible. You should say that.
Well, no, I would say it's easy. Like if you're playing attention, because it's actually fun. I'm liking this.
Yeah, it's fun if it's not exam time. It's not exam pressure.
So this should be this, right?
If no exam, then
No,
how much
no,
study
no.
this?
This is a don't care. We need to
Yeah,
assign a
that's
don't
true.
care. Okay, we need to assign this.
Hmm.
Okay,
You should not forget that. Yeah. Okay.
assign that.
This
later on.
this is
What
also
it
T,
asking?
so left
It's
arrows.
asking vertex 3, right? This bad.
Hmm.
So okay,
Yeah,
then
but we have to anyway solve, na?
Yeah. So then this
So
should not.
let
Then we can let it be there.
let it go. This is left arrows
So
in
this
T.
is
Vertex 3.
so this is a left arrow. Sorry, what? Yeah, so this
नहीं
should be
vertex 3
this,
को left arrow करना है
Yeah,
ना?
so this
नहीं
should be
left left
this.
left not right
and this
not
is,
right left. It's a T.
No, this is a Y junction.
नहीं vertex 3 is T ना, तो उसको उल्टा नहीं कर सकते हो. There is only
Yeah, I'm
left
just
side
checking
arrows.
this right now. This would be a contradiction. next,
Okay, okay.
Right?
Okay, yeah, contradiction. So,
Yeah, this would be a contradiction because this needs to be this
yeah,
and the don't. care,
right.
So contradict.
नील आएगा. क्या बात है?
We are able to do that. In the previous question, what is vertex 2?
नहीं नील ही आना चाहिए ना वो भी.
This thing is y1.
है ही
nil.
पूरा फिगर सॉल्व नहीं
Oh,
हुआ
right,
तो
this
कैसे
will
होगा
nil. Yeah. Sorry, this will nil.
Complete figure is inconsistent.
इसे डराओ मत यार
Nil. Sorry,
Yes.
forgot that. Why did I forget that when
Okay.
this is itself a contradiction?
मैं बोली ना इट्स नॉट डिफिकल्ट